Welcome. Today we take one new chapter, Theory of Quadratic Equation. I first discuss few important formula and tips and then solve some problems. And as I told you earlier that this is for joint entrance main and advanced and also for different state level joint entrance examination. So this is, as you know, most of all of you know, I think, ax square plus bx plus c is equal to 0 is a quadratic equation, provided a naught is equal to 0. Because if a is equal to 0, equation become a linear equation. Okay. Any quadratic equation must have two roots. In fact, any nth degree equation must have n roots. Here, its roots are minus b plus root over b square minus 4ac by 2a and minus b minus root over b square minus 4ac divided by 2a. These are the two roots of this equation uh, for different value of a, b, c. So actually values of roots will change. Normally, if alpha and beta are two roots, alpha and beta are two roots of this equation, then alpha plus beta is equal to minus b by a and alpha into beta is equal to c by a. These two are known as a relation between roots and coefficients ABC. D is equal to b squared minus 4ac. This one, this one. This is known as discriminant of the equation. Next, we discuss nature of roots. For different value of D, capital D means discrimination will depend nature of root. If D is positive, roots are real and unequal. If D is equal to, D means value of discrimination, which is b square minus 4ac. If D is equal to 0, roots are real and equal. If D is negative, roots are imaginary. And if all coefficients of the quadratic equation, that is a, b and c, if they are all real, then and at the same time d is negative, then roots are imaginary and conjugate. It means if d is negative and one root is, say, 1 plus 2i, then other root must be its conjugate, that is 1 minus 2i, provided all the coefficients of the equation are real. Acha, next, if, just 1 minute, a plus b plus c is equal to 0, then one of its root must be 1. One root must be 1. If the equation ax square plus bx plus c is equal to 0 be such that a plus b plus c is equal to 0, so one root must be 1. Next, if a minus b plus c is equal to 0, one root must be minus 1. And these two will help you very lot. If alpha and beta are roots, then its equation will be x minus alpha into x minus beta is equal to 0. That is x square minus alpha plus beta into x plus alpha beta is equal to 0. That is, if roots are given, this and that, its corresponding equation must be this or that. Common root. Next comes common root. Suppose if a1 x square plus b1 x plus c1 is equal to 0 and a2 x square plus b2 x plus c2 is equal to 0 are two quadratic equations. And if the coefficients are such that a1 b2 minus a2 b1 into b1 c2 minus b2 c1 is equal to c1 a2 minus c2 a1 whole square, then they have a common root, and the common root is either b1 c2 minus b2 c1 by c1 a2 minus c2 a1, or c1 a2 minus c2 a1 divided by a1 b2 minus a2 b1. Achha, once again, uh, if these are two quadratic equations and the equations are such that this relation hold good, this is equal to that whole square, that is a relation between coefficients of this and that. In that case, they must have a common root, that is one root common to this and that also. And that common root is alpha is equal to this or that. This is also very important. Next, now I discuss few relation between roots and coefficients. If for the standard equation of quadratic equation x square plus bx plus c is equal to 0 and alpha beta are its roots, then in that case we have number 1 alpha square plus beta square is equal to b square minus 2ac by a square. You can very easily establish it, but if you can keep in mind then it will save some time. Number 2, alpha cube plus beta cube is equal to 3abc minus b cube divided by a cube. Alpha to the power 4 plus beta to the power 4 is equal to b square minus twice ac by a square whole square minus 2 c square by a square. Only these three relation between roots and coefficients, if you can keep in mind, then it will save some time for solving problems. Next, the equation fx is equal to 0 have real roots at x is equal to alpha and x is equal to beta if the curve y is equal to fx and y is equal to fx meet the x-axis at x is equal to alpha, x is equal to beta. It means fx is equal to 0. Fx in general I am discussing not only for quadratic equation but any general equation. Y is equal to fx is equal to 0 have real roots alpha and beta. So provided y is equal to fx meets the x-axis at the point x is equal to alpha and x is equal to beta, and this is true for quadratic equations also. Next, the number of real roots of fx is equal to gx is the number of point of intersection of the curve y is equal to fx and y is equal to gx. That's all about the formula and tips. These are tips. I discuss few problems of this chapter. First problem is problem number 1. If ratio of roots of px square plus qx plus r is equal to 0 be a is to b, then the value of ab by a plus b whole square is number 1 p square by qr, number 1 pr by q square, number c q square by pr, and number d pq by r square. The question is, once again I am repeating, if this is a quadratic equation, it is a quadratic equation, so p naught is equal to 0 and roots of the quadratic equation are in the ratio a is to b. Then we have to find the value of that, and options are these. Now safely we can take A alpha and B alpha are two roots because their ratio is A is to B, A alpha and B alpha. So we must have sum of the roots, that is A alpha plus B alpha is equal to minus B by A, that is minus Q by P. That is, it gives alpha into A plus B is equal to minus Q by P. Next, product of the roots. Product of the roots is this into that. So A alpha into B alpha is equal to C by A, that is R by P. That is alpha square into AB. Alpha square into AB is equal to R by P. Now, from this relation, actually, to get our solution answer, we have to find a relation between A and B in terms of PQR. That is, we must have to eliminate alpha. From this, we get alpha is equal to minus Q by P into A plus B. And from second one, alpha square is equal to R by P into AB. Now, to eliminate alpha, make it alpha square and divide. So from here, alpha square is equal to Q square by P square into A plus B whole square. Now, dividing or putting value of alpha square from here it is R P A B is equal to Q square by P square into A plus B whole square. One P cancels. So AB by A plus B whole square, actually what you want, AB by A plus B whole square, AB is there, A plus B whole square is equal to R into P by Q square. So second option is correct. That is, option B is correct here. Next, second problem is problem number, in fact, 2. It is, problem is the quadratic equation x square plus 15 into mod x plus 14 is equal to 0 has only positive root, only negative roots, one positive and one negative roots, and no solution. So this is a quadratic equation. In fact, instead of x, here mod x is given. It can be expressed as mod x whole square because mod x square positive, x square and mod x square same thing. So its roots to calculate whether both are positive or both negative, or one positive, one negative, or it has no solution. Uh, for this purpose, let us assume that first x is positive. Therefore, the equation become x square plus 15x plus, because mod x is x, and because x is positive, plus 14 is equal to 0. Factorizing, it is equal to x plus 14 into x plus 1 is equal to 0. So root is either x is equal to minus 1 or minus 14 by factorizing it or by solving it. But our assumption is that if x is positive, equation becomes that. But its both roots are negative. So these are not solution of this equation. In fact, if you put x is equal to minus 1 over there, it will not satisfy. You can verify it. So it has no positive root. Next, let us take x is negative. In that case, mod x is minus x. So x square minus 15x plus 14 is equal to 0. Factorizing, it is equal to x minus 14 into x minus 1 is equal to 0. So it has two roots. X is equal to 1 and 14. But you see, we have assumed here x must be negative. That's why equation become that. But our roots is 1 and 14. Both are positive, not negative. So these also are not admissible. So it has no positive root also. So this is negative. So we see that it has no negative root, it has no positive root. So in fact, it has no solution. Though it is a quadratic equation, but it has no solution. Next, problem number 3. The sum of all real roots of this equation, mod x minus 2 whole square plus mod of x minus 2 minus 2 is equal to 0. To find uh, sum of all real roots of that equation, options 5, 1, 4 and 7. Now you see, if it is of that type, say s square plus a minus 2, so we can factorize it. It is actually a plus 2 into a minus 1. A square plus 2a minus a is equal to 0. So a is equal to 1 and a is equal to minus 2. A means here, oh, anyway, this can be written as mod of x minus 2 plus minus 1 into mod of x minus 2 plus 2 of is equal to 0. So either mod of x minus 2 is equal to 1. In that case, x minus 2 is equal to plus 1 minus 1, plus minus 1. That is, x is equal to 3 and 1. So these are two roots. Or we have another option that x minus a minus 1 is equal to 0, that is mod of x minus 2 plus, sorry, plus 2 is equal to 0. That is mod of x minus 2 is equal to minus 2. But this is clearly inadmissible. Why? The mod of x minus 2, it must be positive and it is negative. So this is inadmissible. So we must have two roots, and that roots are 3 and 1. So sum is 4. So option C is correct. So besides that method, you can, as I used in the last problem, first take that x is greater than 2. Then you get a quadratic equation. And then take x is less than or equal to 2, another quadratic equation. So in that case, obtain two roots and then get same result as 4. Okay, today is up to this. I request you to, I request you, if you think that this video is helpful for you, so please like it, share it, and subscribe my channel. Thank you.